Alright, the full system works. This is the Dyne control software. The motor is spinning at 3,000 RPM with 22 Newton meters of torque. This is power supply settings. They don't matter, they're not hooked up. Got my control system here. This is where I command my controller to do whatever it needs to do. This is the DC link voltage, holding quite steadily at 450 volts, measured precisely through this. Come out here. So now we've got our setup. This guy right here is actively measuring the power out of the drive. So just for a rundown, these are large power supplies. They're powering this system. This is a big motor, which is then connected and driving a motor on the other side of that plate. That motor is connected to my drive. I'm pulling power out of these wires into my drive and then dumping it to the resistor behind it. Let's take a look. That looks really noisy. That's just what happens. But here we can see we're at 5.7 kilowatts, 450 volts, and 13 amps. No DC link connection, just resistors and the motor input. And then here is the large resistors and load bank. Got a little extra fan on them to cool them. They get toasty. It's 5 kilowatts. There's the machine. So this is acting as a generator. That is pushing power into here. It's coming out those and into my drive. This is all cooling. Large hydraulic pump, oil to water intercooler. You can see the fluid being collected, fluid and air being collected back from this guy. It gets coming back over here. This hydraulic pump pulls from this big tank, hydraulic fluid or ATF, pumps it up to here and out this hose. That comes into this distribution block and then gets pumped throughout the motor in order to cool it. You can actually see some of the oil, maybe. You can certainly tell the difference when the pump is off because the oil coats everything and then it just stays like very consistent. You can see a little bit of shimmering in there. So oil's running down through that guy, cooling everything, coming back through there and returning up. This is getting water pumped into it down here. So it's an oil to water heat exchanger through this pump system, which is being fed by facility supply plus a little pressure pump to actually get it to flow through the unit. This here is cooling for the generator there, or the motor there. Coming back through here, show you some of the plumbing for all the cooling systems. All through here, similar pumps to what I have just showed you. These are all cooling for the large power supply systems. So there's 2 of these. This here tells you how much cooling water is going through. Random bits of information. Talking about the motor. Hey, what's bus voltage? Things like that. Something to note. This is the absorber, which for a dyne or a dynamometer, I would normally be putting power into the system. But in this case, I'm pulling power out of the system. So that's not an absorber, it's actually a producer. Poster about the ordeal. And then this other supply is what would normally power my drive. But again, I'm using this all backwards and I don't need this. So there's actual power right now is at 0 watts. I'm not pulling any power from that system. I'm regulating it myself into that load. Woo!